Frequently used sequences of behaviors are another area where a complex learning system can conserve resources and also achieve faster behavioral responses. Sometimes the same sequence of actions must be carried out in the same order on many different occasions. In human beings, the examples can be there are lots of sequences of muscle movements that are frequently used when playing the piano, different sequences of muscle movements when walking. There are sequences used when talking, such as the muscle movements to produce certain words. There are sequences of eye movements plus internal mental processes to interpret groups of visual images as nouns, verbs, and so forth, and fit them into a meaningful framework. Thinking processes like mental arithmetic will also require combinations of attention and information release actions in specific orders. Often, once such a sequence has been initiated, it's going to be carried out all the way through to the end. The full process for a sequence of behaviors will begin with recommendations to perform the first action in the sequence, followed by selection of that action. That action will be carried out, and that will be followed by detection of receptive fields in information which would include the fact that the first action has been completed, and these receptive fields would recommend the second action. The second action will be selected and carried out, and there's a further receptive field detection, again followed by a selection process, and then the third action, and so on. The selection processes prior to each action all take time, which lengthens the total time needed for the sequence. But if experience has demonstrated that the sequence of actions is always required in the same order, then a very complex receptive field could be defined that contained information derived from the performance of the first action plus the fact that the sequence was underway. The detection of this very complex receptive field could effectively be interpreted as a command to carry out the next action. Another very complex receptive field could be defined to initiate the next action, and so on. What's happening here is that learning of each next action in the sequence is no longer occurring. So, in the absence of learning, some receptive fields could acquire behavioral command meanings. The result can be a much faster execution of the sequence, because there is no need for the full selection process between each action. So the expected characteristics of such a behavior sequence manager include the existence of different physical structures that correspond with different sequences, extremely complex receptive fields that specify the exact circumstances in which the next action in a sequence will be performed. A role in the timing of sequences to improve their speed will also be a role of this manager. And of course, this manager will have to have direct access to controller behavior.